Assalamualaikum warahmatullahi wabarakatuh. Chapter 1, Introduction to Separation Process. In this topic, we will learn on several subtopics, which is first we will touch a little bit on the introduction of the separation process, what is separation, and also the objective of the separation process. The second one is the definition, which is the mass transfer principles as well as the molecular diffusion. The third one is types of mixtures. We will touch on the two types of mixtures, homogeneous mixtures and heterogeneous mixtures. And the last one, we will touch a little bit on the classification of separation methods, which is for chemical separation as well as mechanical and physical separation methods. In the end of this topic or chapter, you need to gain several learning outcomes, which is first to understand the principles of separation process and various types of mixtures. The second one is define the separation process. And the third one is to differentiate between physical and mechanical separation. Okay, so some of the introduction for the separation process. In the first thing, okay, you need to know the separation process definition, which is it is a technique that transforms a mixture of substance into two or more products that are different in composition, which is this separation process is a major operation in all of the chemical process industry, CPI, and other industries. And two general objectives of separation process. The general objective of separation process is to separate the mixture into two or more individual components and to obtain specified product purity. So, in this topic, you need to have the understanding on the principles and the concept of separation technology, which is very essential in the sense that will enable us to not only identify but as well as choosing the best method in achieving separation and product recovery, while at the same time will also enable us to identify the type of the mixture that we are dealing with. So it is because identification the type of mixture to be separated and choosing the best method of separation is interrelated and dependable with each other. However, it is important to bear in mind that choosing the best method of separation precedes identification of a product mixture. So, as mentioned before, it is very important to choose the best and suitable method for separation and product recovery. For that matter, it is worthwhile to bear in mind again that each and every different method has its limitation as well as the advantages. With that in mind, it is important to choose the best and suitable method which can produce the desired separation and recover of wanted or desired product from the mixtures as specified in the product specification and classification. And with the product limit in terms of product specification and classification, sometimes it will be troublesome and difficult to achieve the required specification and classification by just using only one separation method. In normal cases, more than one separation method need to be chosen which complement to each other in terms of their respective limitation and enhance each other's advantages. For that matter, uh, this different method of separation can be combined in one big separation system or can be assembled close to each other with separation process occurs from one step or stage to the other step until the final step, which at the final step the product analysis need to be done to check and confirmed the product quality meets the product specification and classification. So before we look at each method of separation in more detail, it is important for us to know the definition and concept of two classification of mixture to be separated, and then followed by basic concept in introduction of separation technology, then only we will look into the different types and general classification and of separation technology. Okay, so before we move further, these are the applications that normally used in separation technique: drying of fruit, drying of ceramic items before firing, making juice concentrated with water desalination, producing sugar and salt, demineralization, or we call it as removal of mineral of water, extracting the herbal product from the leaf, separating crude oil to obtain gasoline, and filter suspended solid from river water. So I want to explain more in separating crude oil to obtain gasoline. This is a common separation technique that normally used in chemical process industries, especially for chemical plant. We call this separation technique like a fractional distillation of crude oil. So this fractional distillation separates a mixture into a number of different parts. We call it as fraction. Yeah, this is the fractions. A tall fractionating column is fitted above the mixture with several condenser. Okay, with several condenser in each and every fraction coming off at different height. So the column is hot at the bottom. Okay, at the bottom the column is very hot and cool at top. Substance with high boiling points condense at the bottom, and substance with lower boiling points condense on the way to the top. So crude oil is a mixture of hydrocarbon. The crude oil evaporated and its vapor condensed at different temperature. Okay, if you see this is different temperature uh, in the fractionating column. Each fraction contain hydrocarbon molecules with a similar number of carbon atom and a similar range of boiling point. So for oil fraction, yeah, for oil fraction, this diagram shows summarization of the main fraction from crude oil and their uses for liquefied petroleum gas, chemicals, petrols, jet fuel, diesel fuels, lubricating oils, wax, polish, fuels for ships, and the last one is bitumen. We need to note that the gases live at top of the column, the liquid condense in the middle, okay, and the solid stays at the bottom. So at top of the column, we call it as there is a small molecules exist here, which is contain of very low boiling point, very volatile component. It's flow easily and ignites easily. And for bottom part, we call it as large molecule or high number carbon chain, where for this component or molecules is it has very high boiling point, not very volatile, does not flow easily and does not ignite easily. So this is the hottest part in the fractionating column. So based on this application, there are so many products that come out from the fractionating distillation column. At the top, normally we will produce refinery gases, and then followed by gasoline, kerosene, diesel, fuel oil, and last one is bitumen. And the bottom one, to produce bitumen, we need to heat the mixtures up to 350 degrees C. Okay. And as you go up to the fractionating column, the hydrocarbon have lower boiling points, lower viscosity, meaning they flow more easily, higher flammability as they ignite more easily. Okay, so this is a little bit description on the crude oil uh, separative process. The other application is very simple application where they just have simple separating techniques to get the end product. Okay, so let's move to the separation techniques. There are several separation techniques which actually normally used in chemical process industries. For example, drying process, evaporation process, membrane separation, crystallization, distillation, extraction, ion exchange, and filtration process. Before I explain more in details for that separation process, let us recall back the fundamental of the diffusion process first. So all of the separation process are based on the principles of mass transfer, where the mass transfer definition is the transport of species from one point to another point in a single phase or from one phase to another due to difference in concentration. So in a molecular scope, the mass transfer phenomena is due to the molecular diffusion, and molecular diffusion is a species moving from high concentration to lower concentration in a medium until the medium is uniform. So this mass transfer principles is related with the fixed law theory, where the fixed law theories followed the rules of random walk process, where the molecules will started to vibrate to increase its kinetic energy and bounce with each other, and next it will move to the direction from one point to another point with referring to the high resistance to low resistance, which is if in the form of liquid, it will follow the rules of moving the molecules from high concentration to lower concentration. And if the mixtures is in a gaseous form, so it applies the resistance in terms of partial pressure, where the higher partial pressure will move towards the lower partial pressure until the medium is uniform. So, to make us clear on on the illustration of the diffusion process, for let's say in a mixture, it contains of two different components, which are component A and component B. The component A and component B is separated by a barrier, or we call it also as a partition. So we know that at point number one, which is it contains a very high concentration of component A, whereas at point two, it contains of component B, which is have very high concentration of component B. So what happened if we remove the partition or the barrier from this beaker or these mixtures? The higher molecules or higher concentration of component A at point one will move towards lower concentration of A at point two, where the higher concentration of B at point two will move towards lower concentration of B at point 1, and the process will continuously happen until the medium concentration is uniformly distributed. So this is a basic illustration on the definition of the mass transfer principles. The other application of diffusion process is like drop of liquid dye, sprayed air freshener, shoe odor, dissolve sugar in water. All of the application applies the same fundamental, where the resistance that use or applied resistance must starting from high to low region. And in actually in human body system also applies the same principles of mass transfer, which is at the surface of the lung. For example, the red color is our lung, where our lung is separated between the environment and the blood. So the air is contained in the environment, and the blood is contained in our body, where we know that in the air or in the environment is very high amount of oxygen, whereas in our blood is very low oxygen concentration, and in the air it has low carbon dioxide concentration, where in the blood is contained of high carbon dioxide concentration. So with regards to the fundamental of the diffusion process, the higher concentration region will move towards the lower concentration region. It means that the oxygen will tend to move or diffuse from the air into our blood, which is from high concentration of oxygen will move towards lower concentration of oxygen, which is contained in our blood. And vice versa for carbon dioxide, because the carbon dioxide in our blood is very high compared to the environment. So the higher carbon dioxide concentration in our blood will move towards lower concentration carbon dioxide in the environment. Next, we will move to the types of mixtures. So generally, materials in our world exist in the form of mixtures. So, but however, in the form of mixtures, most of them are useless and not benefit to us due to the limited application ability. So basically, the type of mixtures can be divided into two parts, which are known as homogeneous mixtures and heterogeneous mixtures. So, for homogeneous mixtures, the type of mixture by which the component of mixture are in the same phase with respect to each other. For example, solid-solid mixture, liquid-liquid mixture, as well as gas-gas mixtures. So, the define homo actually refers to the word same or similar. Therefore, in the context of this subject, a homogeneous mixture can be defined as the type of mixture by which the component of the mixture are in the same phase with respect to each other. By here, it means that if you refer to the liquid mixture, it means that all of the components inside the mixture are in liquid form. Same goes if you refer to solid mixture or gaseous mixture. So, it can be said that all of the components inside the mixture are in solid form or in gaseous form respectively. The next mixture is the heterogeneous mixture, which is defined as the type of mixture by which the components of the mixture are not in the same phase with respect to each other. For example, solid liquid mixture, vapor liquid mixture, and solid liquid mixture. So hetero means different or not the same. For that matter, heterogeneous mixture can be defined as the type of the mixture which component of the mixture are not same in the phase with respect to each other. Therefore, it can be said that if you refer to solid liquid mixture, it means that the mixture consists of one component of mixture in solid form, while the other component in the liquid form. The same goes if you refer to solid vapor gas mixture or vapor gas liquid mixture. From here, it can be said that one component is in solid form while the other component is in vapor or gas form, and one component is in vapor or gas form while the other component is in liquid form respectively. So at this point onwards, it is important if you can distinguish or differentiate between homogeneous mixture and heterogeneous mixture, because this is very essential and important in order to understand the concept which will be discussed under each method and separation. In addition, as previously mentioned in the preceding page, uh, the type of mixture is directly related to the type of separation to be implemented. In fact, it can be said that it is the first step before choosing and implementing separation technique method to achieve separation and purity of the product. So now let us look at the method of separation by which is given briefly in the following page, in the following slide. This method of separation basically can be divided into chemical separation and mechanical separation. So we will firstly look at brief in the definition of chemical separation and mechanical separation. Then we will look on the example of chemical and mechanical separation. Okay, so for and classification of separation method, separation process basically can be generally classified or divided into two types, which are chemical separation and mechanical separation. The respective definition of these two methods as well as example of method under chemical separation and mechanical separation will be shown respectively as given in the slide later. Okay, so we move to the chemical separation first. Okay, now let us look at the first method of separation, which is chemical separation. The description of chemical separation from the reference material can be given as chemical separation is carried out based on physical chemical properties differences in the molecules themselves, and on mass transfer of the molecules, the mixtures are separated into two phases because of the molecular differences in chemical separation. In order to separate or remove one or more compounds from its original mixture, it must be contacted with another phase. So based on the description, as I mentioned before, it can be understood that these three conditions of chemical separation must exist, which is first, in terms of physical chemical properties differences, it means that the mixture consists of compounds with a different physical and chemical properties. And the second one is two-phase is concerning the state of the mixture either in solid, liquid and gas or vapor. This is related with arrangement of the atom or molecules of the compound, which has been covered in general chemistry. You already learned it in the general chemistry. And the last one is about the mass transfer. The mass transfer is the mechanism whereby the molecules are moved from one mixture to another mixture. So in order to separate or extract a compound from a mixture, another medium or phase is required in order for a transfer to occur. So the medium or another phase could be solid, liquid and gas or vapor, which truly depends on the method of separation process technology. So we already look into brief description on chemical separation, which is one of two general classification of separation technology. So some of the example on the method of separation under chemical separation is like distillation, absorption, stripping, evaporation, crystallization, drying, adsorption, ion exchange, as well as membrane separation. So I will give you a briefly concept on this method under chemical separation. So we will touch on the distillation first. So as you see in the definition, distillation is the separation of desired compound based on their difference in boiling point and volatility. Actually, there are different descriptions concerning the process of distillation, which are some of the books says that it is a volatile vapor phase and a liquid phase that vaporize are involved, where the distillation of an ethanol water, for example, ethanol water solution, where the vapor contains a concentration of ethanol greater than in the liquid. So in the distillation of crude petroleum, for example, various fractions of gasoline, kerosene, and heating oils are distilled off. And some of the books states that distillation is similar in concept to evaporation actually, but for distillation, it allows the capture of substance which evaporated. Meaning that distillation is a process of heating the liquid to its boiling point, condensing the vapor back to a liquid by cooling method, and then collecting the liquid in the distillate product. So since different substances have different boiling point, controlling the temperatures allows separation to occur. As an example, what I explained before in the previous slide, for the fractionating column, the crude oil is refined to various products such as naphtha, gasoline, kerosene, fuel oil, and lubricating oil through a fractional distillation process. And based on this description of distillation, it can be seen that the separation of desired compound involve only one phase, which is in liquid phase. So therefore, it can be simplified or conclude that distillation involve the separation of desired component based on their different in boiling point in volatility. The more volatile compound will vaporize and the condense and then condense before being collected, while the less volatile component or compound will remain in the column or at the bottom of the distillation column. So that is the basic principles of the distillation process. Okay, so next we will move to the absorption process, where for the absorption process, this is actually the desired component of gas or vapor is to be separated or extracted from a mixture of gas, a liquid will be used as a solvent to absorb the desired gas into a liquid. Okay, so it means that in the absorption process, it is when the two contacting phases are gases and liquid, where normally in the inlet gas, it contains of the pure air plus with the harmful gas. So the job of the distillation, the job of the absorption process is to remove the harmful gas from the air mixtures. So by using a liquid solvent, which will normally flows from top to the bottom of the gas absorption, it makes that the liquid solvent will absorb the harmful gas from the air mixtures that coming from bottom to top, and it will settle down at the bottom of the column, which means that the liquid that flows at the top at the bottom of the absorption column will contain of solvent plus the harmful gas, which is already soluble in the liquid solvent. So the rest, the pure air, which less amount of harmful gas will be released in the environment. So in that cases, the summarization of the definition of the gas absorption is the desired component, which is in the gas, is to be separated by using suitable liquid solvent based on its solubility to enhance the gas absorption process. And the last one for gas absorption, at the bottom of the gas absorption actually contain a stripping process, where actually it is the reversible process of gas absorption, where the reverse of gas absorption, we call it as stripping or desorption, and the same theories and basic principles hold like absorption process. So the definition of the stripping is once a solute is dissolved in a solvent, it is often necessary to separate the solute from the absorbent in a stripping operation to recycle the solvent back into the absorber. So from these two description given in the definition of absorption, and as well as a stripping process, it can be said that the stripping also involves two phases, which are liquid that consists of mixtures between liquid solvent being used for absorption, and solute which is being absorbed into the solvent, and vapor that is to dissolve or strip the solute. In other words, it can be said that stripping or desorption is the reverse process of absorption, whereby the liquid mixture from the absorption process is to be separated by using vapor, which is to dissolve the solute from the liquid mixture into the vapor. This is done in order to regain the liquid solvent to be recycled or reused back for absorption process. So gas absorption and stripping process is very relate with each other. Alright, so next we move to the next method under chemical separation, which is evaporation process. Okay, so there are different description on evaporation which can be given as stated statement, which is a method of removing water and organic solvent from liquid mixture in order to get more concentrated product. So actually evaporation is refers to the removal of a relatively large amount of water from material. In evaporation, the water is removed as vapor at its boiling point. In evaporation also, the vapor from a boiling liquid solution is removed and more concentrated solution remains. In the majority cases, the separation process called evaporation refers to the removal of water from an aqueous solution. And some of the book also stated that evaporator may be considered as liquid dryers or concentrators that separate solvent from a solution by evaporation process. In most cases, the solvent is water. In most cases lah. Okay, so evaporation as a separation process is distinct from distillation. It's different with distillation in that the solute is non-volatile and a high degree of separation can be achieved in one stage only. So based on this statement concerning the evaporation process, it can be understood that the mixture in a liquid form or a homogeneous type of mixture. Therefore, the concept of evaporation can be summarized as a method of removing water which acts as a solvent or organic solvent from a liquid mixture. The evaporated water or organic solvent is discarded or dispersed to the atmosphere and leaving the desired product in more concentrated form. So that is description on the evaporation process. So for the crystallization process is the adjustment of temperature, increase or decrease to liquid mixture until desired product is obtained. So for crystallization, there are several description based on the crystallization statement. Some of the books state that it is a solute component soluble in a solution, which can be removed from a solution by adjusting the conditions such as the temperature or the concentration so that the solubility of one or more solute component is exceeded and they crystallize out as a solid phase. And some of the book also state that for this crystallization, the product that will come out is like the precipitation or the crystallization, where that process is actually a solution when the solution is cooled until a solid precipitate to form a solid phase, which is we call as precipitate. And these two phases mixture, which is the liquid and the solid, then may then be further separated by the cantation or filtration. The word crystallize is more specific and is used when the solid form crystals rather than amorphous solid, or we call it as powder or granules. So crystals have well-formed planar faces and regular geometric shape. So, in other words, for crystallization statement or definition, it is actually a solution when the solution is heated to evaporate the solvent and is then cooled through is cooled through careful temperature schedules to obtain predetermined crystal size and composition. Then the slurry is either passes through a series of settling tank or filtration unit. And sometimes we can say that for crystallization, under certain operating condition, dissolved materials in solution are recoverable in solid form by precipitation upon cooling, upon removal of solvent or addition of precipitation agent. And based on that definition, the crystallization, or also known as precipitation, is very important to realize that initially the mixture which contain the desired compound is in the form of liquid. Then the temperature is adjusted so that the desired compound becomes solid. Okay, so the definition of crystallization can be summarized as crystallization is a method of separating whereby the mixture which consists of desired compound is in liquid form. The temperature is adjusted by either one of the following method. The one method is the temperature is increased to vaporize the undesired compound and left the desired compound which is then cooled until it turns to liquid. And finally, the crystal are collected by using filtration process. The second condition is the temperature of the mixture is decreased in order to solidify the desired compound, which is then filtered from the mixture. So that is the crystallization definition. And next we will move to the drying process, where the drying process definition is the method of removing water or organic solvent from wet solid at a specified moisture content. So basically there are briefly description on the drying process concerning the principles and concept of drying. which is drying generally means removal of relatively small amount of water from material. And in drying process, the water is usually removed as vapor by air. And the main purpose of drying process is to remove liquid from a liquid solid system to produce a dry solid. Generally, the liquid removed is water, but drying can be also be used to separate organic liquids from solid. So, therefore, from this statement, it can be seen that the mixtures of dry is basically a heterogeneous, which is solid and liquid. For that matter, the concept of drying can be summarized as drying generally involve the method of removing of water of organic solvent from wet solid at a specified moisture content. The water or organic solvent being removed to the atmosphere in the form of vapor. Okay, so we finish on the drying method. Chemical separation, which is adsorption. So adsorption is a desired compound in a mixture of liquid or gas. Sometimes we call it as fluid, which will be separated from other compound by the usage of an absorbent, which is in form of solid. So, in absorption, there are basically two descriptions concerning the method of adsorption as given in the reference material, which some of the books stated that the adsorption is one or more component in a gas stream which are absorbed on the surface of the press of a solid adsorbent and the separation is obtained. And the other definition of adsorption is separation process, which certain components of a fluid phase are transferred to the surface of a solid adsorbent. The selective absorption of components of an adsorbent followed by removal of this component through regeneration forms the basis of adsorption. So, based from the brief description, it is important to bear in mind that the mixture as well as the desired compound is in the form of liquid or gas. Meanwhile, the medium where the desired compound is to be transferred is in the form of solid. Therefore, the method of adsorption can be summarized as in the statement, which is a process whereby the desired compound in a mixture of liquid or gas will be separated from other compound by the usage of an adsorbent, which is in the form of solid. And next, we will move to the next method of under chemical separation, which is ion exchange, where the ion exchange definition is like similar with the adsorption, which is the difference by having chemical reaction between ions of mixture with ion of solid ion exchange resin. There are this different description on ion exchange, which can be given as a follow statement, which is based from the materials reference is first, ion exchange is also similar to adsorption in that solid particles are used in the separation process and regeneration is necessary. But however, a chemical reaction is involved, yeah. And the other definition of ion exchange is like the process which are basically chemical reaction between ions in solution and ions in an insoluble solid phase. The technique used in ion exchange so closely resemble those used in adsorption that for the majority of engineering purposes, ion exchange can be considered as a special case of adsorption. Yeah, so in ion exchange, certain ions are removed by the ion exchange solid. So since neutrality must be maintained, so the solid releases replacement ions to the solution. And also, it can be defined that ion exchange is a chemical reaction wherein an ion from solution is exchanged for a similarly charged ion attached to an immobile solid particle. So based from the statement that I give you about the definition of the ion exchange, it is all concerning the concept of ion exchange. So therefore, it can be summarized as in the statement. Ion exchange is a very special case of adsorption since it is similar with adsorption, but with the difference by having chemical reaction between ions of solution with ion of solid particles or ion exchange resin. As a result of the chemical reaction, the ions of solution exchange with ion of solid particle based on similarly charged ion. So that's the explanation on the ion exchange. And the last method of under chemical separation is the membrane separation. Is membrane separation is um, separating the desired uh, compound from a mixture by the usage of membrane. And actually there are several descriptions concerning membrane processing, which is the one of the method of separation under chemical separation. For example, the definition of membrane processing is like the membrane itself is a relatively thin solid membrane controls the rate of the movement of the molecule between two phases. And this membrane processing or membrane separation technique is the method of separating gases or liquid mixtures by the usage of semi-permeable membranes, which is acting like a filter. So this membrane allows one or more constituent of the mixture to pass through more readily than the others. And sorry, and this membrane processing also the type of separation which is accomplished the usage of specially prepared membranes by selective by prepared membranes that selectively permit one or more components of a feed stream to pass through the barrier or the membrane while retarding the passage of other components in the feed stream. So based from that definition or description, it can be seen that the membrane is basically in the form of solid, while the desired compound is in the form of either liquid or gas in a mixture of liquid or gas respectively. So therefore, the description of membrane processing given as in this statement, which is the method of separating the desired compound from the mixture by the usage of membrane filter, which only allows the desired compound to pass through and left behind the other compound in a mixture. So this method is known as membrane processing. Okay, so for the next method under chemical separation is liquid-liquid extraction. So liquid-liquid extraction is a desired compound in a liquid mixture to be separated by using a liquid solvent. So the criteria of the solvent which is the desired compound must have high solubility towards the solvent. There are also many definitions concerning the method of LLE or liquid-liquid extraction. So one of the definitions stated is regarding the liquid-liquid extraction when the two phases are liquids uh, where a solute or where the solutes are removed from one liquid phase to another liquid phase. And sometimes we define the LLE or liquid-liquid extraction is like a solution which containing the desired component A and solvent C is mixed with another liquid B. So a fraction of A is then extracted from C into B. But however, the B cannot be completely miscible with C. The greater the immiscibility between B and C, the better the process. So the B rich phase containing A has to be easier to separate than C rich phase. Otherwise, the whole extraction scheme become unnecessary. So in liquid extraction, the important stream that should exist in the process is the feed stream, the solvent stream, the raffinate stream, as well as the extract stream. So the feed will contact with the solvent stream, and the process of extraction will occur inside the process, and the output or the outlet stream will be the raffinate stream, which is settled down at the bottom of the process, and the extract stream will remove or exit in the upper stream of the extraction process, which in the extract stream there will be high concentration of solute, where the in the raffinate stream or the outlet stream at the bottom of the extraction unit must contain of lower concentration of solute or our desired product. That's why the definition is for the liquid extraction is the a desired compound which in the mixture and in liquid phase is to be separated or extracted. So to achieve this, a solvent which is also in liquid phase is needed to be used, and the criteria of choosing the solvent is based on the desired compound that has high solubility towards the solvent. So that is the definition of the liquid extraction. And we also have another kind of extraction process, which is we call it as leaching process. So the other name of leaching process is SLE, solid liquid extraction, where leaching process is the process of separating solute, which is the desired compound in the form of solid from its solid mixture with the usage of a solvent in the form of liquid. So previously in liquid extraction, the solvent that we are using to extract the solute from the mixtures is in liquid phase. But in leaching, okay, in leaching process, the solvent that you are going to use is yes, also, the liquid also, but it will need to extract the solid from the solution. Okay, so the other definition is the leaching is a process of uh, if a fluid is being used to extract a solute from a solid. Sometimes leaching also refers to the extraction of a soluble constituent from a solid by means of a solvent, and sometimes we call this method is a method of removing one constituent from a solid by means of a liquid solvent. And in order to separate the desired solute or to remove an undesired solute component from the solid phase, the solid is contacted with a liquid phase, which is the solvent. So the two phases are in intimate contact, and the solute or solutes can diffuse from the solid to the liquid phase, resulting in a separation of the components originally in a solid. So this separation process is called solid liquid process, solid liquid extraction, or simply says as leaching process. Mechanical separation. So now the attention to the next method of separation, which is known as physical mechanical separation or simply mechanical separation. The description of mechanical separation is carried out by using mechanical physical forces, and will be acting on particles, the liquids or mixtures of particles and liquids. So among the mechanical physical forces are gravitational, centrifugal, mechanical and kinetic forces. So as a result, the particles uh, or fluid are separated because of the different effect produced on them by this force. By referring to the statement uh, regarding the mechanical separation, it can be understood that mechanical physical forces such as gravitational, centrifugal, mechanical, as well as kinetic forces are applied to solid, liquid, or mixtures of both solid and liquids in order to cause separation of desired product. In order to achieve mechanical separation, the specific method used are listed as in the slide, which is by using filtration process, by using centrifugal separation process, as well as by using settling or sedimentation centrifugal filtration process. So let us look briefly on this concept of using these three methods of mechanical separation, starting with filtration. So there are basically several description or definition concerning the principles and concept of filtration, which is infiltration. A pressure difference is set up that causes the fluid to flow through small holes in a screen or cloth, which block the passage of the large solid particles. In turn, it will build up the cloth as a porous cake. So, the other definition of the filtration is um, the solid particles, which is in a liquid or gas, are removed by passing the mixture through a porous medium, which will retains the particles and passes the liquid. So, as summary, the concept of the concept of filtration is actually the filtration is used to separate a solid from a liquid or solid from gas. In this case, the mixture is put through a porous medium, which is often we call as filter paper, in which the size of the pores allows liquids or gas and dissolved solids to pass through, but retain solid particles. So this is essentially like using a strainer, but with much smaller openings. The clear liquid phase obtained is called the filtrate. So from that statement that I explained before, it can be understood that the method of filtration is used to separate a mixture which contains solids and liquid for a solid liquid mixture, but also used to separate mixture which contains solid and gases for solid gases mixture. Solid is the desired product, while liquid is an unwanted product for the case of solid liquid mixture. For the case of solid gases mixture, solid is again the desired product while gases is an unwanted product. Therefore, in order to achieve separation, solid and liquid or solid and gas need to be separated by the usage of porous medium such as filter paper. So the concept of filtration is about the same with membrane processing uh, in the chemical separation, but the difference is in the membrane processing or membrane filtration is used to separate liquid mixture as well as gases mixture, where in filtration process is used to separate mixture which contains solid and liquid or solid and gas. So that's the explanation on the filtration process. So next we move to the centrifugal filtration. So it is unfortunate at the time of writing that not much description is given to this type of mechanical separation. But however, there is only one brief statement or definition which can be given as in this statement. Centrifugal separation is the process of separating a suspended solid in a liquid by high-speed rotation. So the centrifugal filtration is in the second type of centrifugal separation process, where the centrifugal filtration occurs, which is similar to ordinary filtration, where a bed or cake of solid builds up on the screen, but centrifugal force is used to cause the flow instead of pressure difference. And based from this statement, it can be understood that there is not much different as compared to filtration as been mentioned earlier. So because this method also deals with either heterogeneous mixture, which is solid liquid or solid vapor gas. solid vapor. So the only difference is concerning the causes of flow with pressure different is applied for normal filtration, but obviously centrifugal force is used for centrifugal filtration type. Okay, and last but not least is about settling process. So settling process is also known as gravitational settling, and it's separating solid from the mixture solid liquid by the usage of gravitational force, and the solid will slowly drop to the bottom of the container or tank. So the other definition of settling process is in settling and sedimentation, the particles are separated from the fluid by gravitational force acting on particles of various size and densities. And sometimes the definition that we can get from the book, okay, sometimes it's stated like the solid particles or liquid drops are separated from a fluid by gravitational forces which is acting on the particles of the particles or drops. So the fluid can be a liquid or a gas. So to summarize the concept of settling, which is based from the statement that I've mentioned before, the settling, or also known as gravitational settling, is a method of separating solid from the mixture of solid and liquid by the usage of gravitational force. So here, the solid, which has higher density, then obviously slowly drop to the bottom of the container or tank, which is then sucked by pump to separate the solid of the usage of filter. Sorry. So here it can be seen that the method of settling not cannot stand on its own. So this method needs to come together with filtration in order to achieve complete separation of solid from the filtrate or the liquid remains of the mixture. So with this we already end of chapter 1.